This lecture tutorial focuses on two types of volcanoes. Ones that have a very gentle appearance, almost like a hill, and then others that look very much like a typical volcano that you might think of, with a rather pointy top and much of it above the snow line. The learning objectives are to use cross-sections or photos to differentiate between shield volcanoes and stratovolcanoes. So those are the two kinds of volcanoes that are addressed in this activity. And you're also going to predict the type of volcano and eruption style given the composition or viscosity of the magma. This first part explains that different types of lava erupt to form different types of volcanoes, and that's because of their viscosity. If they're thick, they're going to flow in one particular manner, and if they're thin, they're going to flow in a different manner, and that's going to result in two very different looking volcanoes. The volcano type can also indicate if the eruptions will be explosive or peaceful. Now, felsic lava is made up mostly of silicon and oxygen atoms, and they are bonded in long chains, so it makes that kind of lava rather sticky, and gas gets trapped in that kind of lava. Mafic lava, on the other hand, has a lot of iron and magnesium in it, and that breaks up these long chains of silicon and oxygen. Which of these two types of lava do you think would flow more easily? That would be the mafic one, because this one doesn't have all of those tangled spaghetti strands, if you want to look at it that way, that are holding things tightly together, that are viscous. On the next page, in the diagram below, are two simplified profiles of volcanoes. The profile of the volcano can give us a clue if it was built from slow flowing thick lava, or if it was formed by lava that flows fluidly and spreads out. So the first one you could think of as toothpaste, thick and slow in terms of flowing. The second one you can think of as honey. It flows readily and it spreads out easily. So on the diagram below, label each volcano as either mafic lava flows easily and spreads out, or felsic lava flows slowly and piles up. The answers are shown here. The shield volcano that has this very gentle slope is formed from mafic lava that spreads out. The much smaller but steeper stratovolcano forms from felsic lava that flows slowly and piles up. I should mention that stratovolcanoes are often associated with intermediate composition magma, which would be andesite, but they also do erupt felsic material, and in fact, if you recall from the video Rocks 7.4, when I talked about California volcanoes, several of the volcanoes in Northern California are stratovolcanoes, but they have erupted rhyolite in the past. On the diagram, label each volcano as rhyolite or basalt. The shield volcano is basalt, the stratovolcano is rhyolite, or as I said, sometimes andesite. Which type of lava will easily let gases escape? That would be the mafic lava, because it isn't sticky, it's fluid and low viscosity. Number 5, on the diagram below, label each volcano as explosive or peaceful. So the mafic lavas are the peaceful eruptions, and the felsic ones are the explosive eruptions. Based on the type of eruption, which volcano would you rather live next to, a shield volcano or a stratovolcano? Explain your answer. Well, before I answer that, let's go on to number 9, because two students are debating which they would choose. Student 1 says, I'd prefer to live next to a stratovolcano because the lava is so thick and viscous that they don't have a long lava flow. The lava flows will slow down and stop before they get to my home. Student 2 says, but stratovolcanoes have explosions that can't be predicted, so they are more dangerous than runny lava. I would prefer to live next to a shield volcano where the runny lava flows in a predictable pattern. So who do you agree with? Turns out that student 2 is right, and a shield volcano is a safer volcano to live by. Why is that? Well, even though it's true that felsic lava might not flow very far, these types of eruptions are extremely dangerous because they commonly erupt pyroclastic flows over large areas. And if you forgot what a pyroclastic flow is, here's a picture. This particular picture is from the eruption of Mount St. Helens in 1980. Finally, the photograph below is a volcano in the United States. What can you determine about the volcano based on the picture? What kind of type of volcano is this? Well, given the two choices, this is a stratovolcano, or sometimes called composite volcano. This is not a shield volcano. What about the lava that made this volcano? Well, that was going to be either felsic or, as I mentioned, possibly intermediate. What about the rock type? Again, we have two options: rhyolite if we had felsic lava, or andesite if we had intermediate lava. Regardless of the type of lava, this type of volcano is explosive and dangerous in its eruption style.